All right, let's talk about one of the most critical skills for any data engineer, moving data. Seriously, getting data from point A to point B safely and efficiently is the name of the game. And to make this super practical, we're going to use a case study I think you'll get right away. A food delivery app we'll call Hungry Now. Okay, let's jump in. Just think about that for a second. Every single time you place an order, a restaurant updates its menu, or a driver's location pings on the map, that's all data in motion. It is literally the lifeblood of the entire business. You stop that flow, and the app is dead in the water. The business is completely flying blind. So that's the big question, right? How do you become that heart? The thing that reliably pumps all that vital data exactly where it needs to go at just the right speed? Well, in this explainer, we're going to break down the professional-grade skills you need to power a company like this. So first, let's really get a feel for the problem at Hungry Now. You've got data pouring in from everywhere, users, restaurants, drivers. It's kind of chaotic, and our job as data engineers is to bring some serious order to that chaos. And to solve this puzzle, you need the right tools. So let's open up the toolkit and walk through the 5 core ways, the 5 professional methodologies for moving data. First up is the classic, the old reliable, batch ETL. This is our workhorse for things that don't need to be right this second, like financial reports. It works on a schedule, say once an hour. We extract all the new data, we transform it to get it cleaned up and in the right shape, and then we load it into our data warehouse for the business folks. Now, the key here is understanding the trade-off. Batch ETL is pretty simple, it's predictable, and it's cheap to run. But the data is always a little stale, maybe up to 60 minutes old in this case. That is totally fine for a dashboard showing high-level KPIs, key performance indicators, but for a live feature, no way. It's a non-starter. So for that live track your order map feature that we all love, we need something completely different. We need streaming. Instead of waiting for a schedule, we grab those driver GPS pings the instant they happen, process them immediately, and push that data out to power the live map on your phone. With streaming, the stakes are way higher. Our goal, our service level agreement, isn't measured in minutes, it's measured in seconds. This stuff is way more complex, and it comes with a critical guarantee we have to provide, exactly once processing. All that means is every GPS ping gets counted one time. No duplicates, no dropped locations. It has to be perfect. Okay, next up. What happens when a restaurant just changes the price of one item? It would be super wasteful to copy their entire menu over again, right? Well, that's where Change Data Capture, or CDC, comes in. It's a really clever way to just peek into the database's internal log file, find only what changed, and send just that tiny update downstream. So the whole point here is efficiency. CDC puts almost zero extra strain on the restaurant's live database, which is absolutely critical for their performance. We're not moving data we don't need, and we make sure our analytics see that new price within just a couple of minutes. Of course, not all the data we care about is our own. For stuff like restaurant reviews from a partner website, we have to use API ingestion. This is basically a process that, on a schedule, calls out to some external service, pulls in their data, and then we have to reshape it so it fits nicely with our own internal data. Now, the big challenge here is that we don't control that source. The third-party API could go down, or they might get mad if we ask for data too often. So a professional-grade pipeline has to be built with things like automatic retries and really solid error handling. You just can't let a shaky partner bring your whole system down. And finally, the modern powerhouse, ELT. And yep, you noticed the letters are flipped from ETL. It's a big deal. Here, we extract the data and immediately load the raw, messy version right into the warehouse. The transformation happens later, inside the warehouse, using its massive computing power to do all the heavy lifting. The beauty of ELT is pure speed and flexibility. We get that raw data to our analysts incredibly fast. Then they can shape it and model it any way they want, without having to wait on a data engineer. The only catch? You gotta keep a really close eye on those warehouse compute bills, because they can get big. So, we've got our 5 methods, we've got our toolkit, but just knowing the tools isn't enough. A true professional knows exactly when to use each one, so let's look at a simple framework for making that choice. This decision matrix right here, this is your cheat sheet, honestly. You just read it from left to right. Start with your use case. What are you trying to do? Need hourly KPIs? Boom, the answer is batch ETL. Need to sync a source database in near real time? Use CDC. This table directly maps the business problem to the right technical solution. It's that simple. Okay, let's level up for a second. Let's talk about building pipelines that are resilient. See, a professional system doesn't just work on a good day. It works reliably every single day, and it knows how to handle errors gracefully when things go wrong. You build trust, both for yourself and for your users, with a serious validation checklist. Are you checking that the number of rows you pulled out matches the number you loaded in? Are you actively monitoring if the data is fresh enough to meet your SLA? These aren't nice-to-haves. They are absolutely essential for building systems that people can trust to make real business decisions. And look, things are going to break. It's inevitable. The difference between a pro and an amateur is having a plan, a runbook. If an API goes down, you're prepared. You serve the last good data you have, and you automatically retry. If you get duplicate data, you use what's called idempotent logic, which just means running an update twice has the same result as running it once. This is all about proactive defensive design. So you did it. You built an amazing, resilient pipeline. Now, how do you prove it in your portfolio or in an interview? It's all about translating that technical work into business impact. Now, this is a powerful statement. Why? It names the method, CDC. It names the tool, Debezium. And most importantly, it names the business outcome with a hard number, a P95 lag of under 2 minutes. That means 95% of all menu updates were live in our system in less than 2 minutes. That proves you get the why behind what you built. Here's another great one. It identifies the business feature, the GPS pipeline. It states the critical performance metric, latency under 5 seconds, and it includes a key technical detail that screams quality, exactly once upserts. This tells me you're focused on both high performance and correctness. In this final example, this shows you care about reliability. It shows you're not just a coder building features, you're an engineer building trust. You're explaining how you proactively protected the business from making bad decisions based on bad data. That is a senior-level way of thinking, right there. So there you have it, the 5 core patterns for moving data like a pro. From old-school batch to real-time streaming, every single one has its place in your toolkit. The only question left is, which one are you going to master first? Thanks for tuning in.